So if let's say that we have something like 3x plus 2. This is an example of an expression. An expression is essentially part of an equation. Okay, until we define equation, it makes a lot of sense, but it's really going to be the left-hand side or the right-hand side of an equation. That's an expression. Expressions don't have equal signs. There's nothing to solve here. I can't ask you to solve an expression. You can't do it because there's no equal sign. What you can be asked to do is you can be asked to simplify expressions, and that's what you were kind of asked to do yesterday with like this problem right here that we did yesterday. That's an expression. There's no equal sign in it. And you can simplify expressions, but you can't solve them. So that's an expression. When we take that expression and set it equal to something, now we have an equation. And in an equation, there's something for you to solve. We want to find, in this case, the value of x, or we want to find the value of whatever that variable may be, using the different properties that we have to solve equations. So an expression, no equal sign. You can simplify it, you can't solve it. Equations have an equal sign. An equation you can solve. So let's go ahead and solve this equation. In order to solve equations, again, you've been doing this for quite a while now. This shouldn't be overly difficult for you to do at this point. Remember that anytime you solve an equation, your goal is to get the variable on one side, the constant on the other. Okay? When I have variables on both sides of the equation sign, again, when I say both sides, you can think about this line being here. I'm not going to draw the line in there. Okay? Just know that I mean on both sides of the equal sign. I'm going to move the smaller of the two first. So I'm going to subtract 2x from both sides of this equation. Now at this point, you could draw this line in here and then kind of do the math. I like to save some time a little bit here and say, okay, I moved the 2x by subtracting 2x from both sides. That's going to leave me an x over here, so I don't want this number over here. So I'm going to subtract this number at the same time. Because it's a plus 2, I'm going to go ahead and say, well, I can just go ahead and not do that one. I can go ahead and subtract 2 at the same time. And notice how I've got them nice and lined up. 3x minus 2x, that just leaves me with x. 2 minus 2 is nothing. 2x minus 2x is nothing. Negative 4 minus 2 is negative 6. That's my solution for this equation. And you're done. That was, that's the difficulties of what you're going to have to do today. I mean, a lot of it's going to be solving these different equations and using different properties to solve them. So that's just a couple of examples of things that you might see today. It's going to kind of start out with basic. You might have something like 2x minus 4 equals 14. Go ahead and solve that real quick. So add 4 to both sides. 2x equals 18. 2 times what is 18? X is equal to 9. At this point in your life, is it necessary that you write down that plus 4? No, it's not. If you know you're adding 4, just 2x equals 18 is perfect enough for me. And then they're getting a little more difficult. Okay, next one, let's go with 3 and then x minus 6 plus 2 equals 2x plus 4. So it's a little bit more complex now. In this case, you're probably going to want to do the distributive property first. It's kind of a hint. Do the distributive property first. 3 times x is 3x. 3 times negative 6 is negative 18. Then you've got something that looks like this. Now, something I've been telling people lately is that anytime you're trying to solve an equation, you don't really want more than 2 terms on each side of the equal sign. If you have more than 2 terms on each side of the equal sign, you've got to combine like terms. We've got 3 terms over here, so combine first. So negative 18 plus 2 is negative 16, and that's equal to 2x plus 4. Now I'm going to subtract 2x from this because that's going to give me a positive on the left-hand side. But then I'm also just going to add 16 at the same time. So you end up with x is equal to 20 for your solution, and you're done. And get that distributive property done and taken care of first. And then once you've got that distributive property done and taken care of, you can do the other steps. Any questions with that one? Okay. Next, let's go 4x minus 2x minus 3 is equal to 2x minus 7. Okay. And we'll do this one together because something unique happens with this one. So 3 terms on the left-hand side. Don't like 3 terms, so we probably got to combine terms. So 4x minus 2x is 2x. So you've got 2x minus 3 equals 2x minus 7. Subtract 2x. That gives you negative 3 equals negative 7. Is that true or false? This is false. If you get a false statement, there is no solution to the problem. Meaning there's not a value of x that you could put in there that's going to make that work. It does not work. If you get a true statement, say you did all this and you got a true statement. So say your equation was 2x minus 3 equals 2x minus 3. Subtract 2 x's from both sides. You're left with negative 3 equals negative 3. If that's the case, your answer is true. The solution to this then is all real numbers. True means all reals. False means no solution or the empty set. Again, true is all reals, false is no solution. Last one, because everybody loves fractions so much, let's go negative 5/7 x equals 10. There's a couple ways you could do this. What's one way to do it? Could I multiply both sides by? If I multiply both sides by 7, that leaves me with negative 5x equals 70. You multiply by whatever's in the denominator. Divide by negative 5. X equals 14? Negative 14? Yeah. X is equal to negative 14. That's one way to do it. Probably the easier way to do it because you're going to do the same thing the second way that you could do it. The second way you could do this one, you have negative 5/7 x equals 10. This means multiplication, right? Negative 5/7 times what is equal to 10? So instead of multiplying by 7, how do you get rid of multiplication? Division. You could divide this by negative 5/7. So this divided by negative 5/7. Those are gone now, leaving me with x, 10, but we don't divide by fractions, right? We multiply by the reciprocal, which is 7/5. Well, you still get 70 over negative 5. You get the same answer either way. Which way you choose to do it, it doesn't matter to me. Whichever way works best for you. Okay. So the big key out of today, what's the difference between expressions and equations? Expressions don't have equal signs. You can combine like terms. That's about all you can do. Equations are equal to each other, and you can solve something. And then you got a bunch of questions that you have to solve as far as that goes. What do I mean by a bunch? I mean you have a whopping 10 questions.
That's way too much.
On your assignments. And you don't have any time to work on it, so I would plan on you not getting done.